This video will showcase some of the concept art I generated for Beyond Dying Skies 2. We have chosen to make the next generation engine compatible with WebGL 2 and WebAssembly to make the development process more accessible. Please see the links in the description to run the demos displayed in this video. We will begin with the WGS84 UV sphere, unwrapped onto the Blue Marble dataset from NASA, currently being rendered at 8K resolution texture. The sphere has basic Phong-based materials but is rendered at the correct scale. Our satellite is orbiting Earth at 1,400 kilometers. The International Space Station usually orbits around 350 kilometers above Earth. At this distance to the Earth, the current texture was too pixelated, so I chose to render from the perspective of an average satellite. We can see that the texture resolution for this close of a flyby is adequate for displaying a realistic space environment. However, if we wish to get closer, we will need to use higher resolution textures or use a level of detail texture tree approach to load smaller, higher resolution textures that are visible to the camera. At this point, we are naively rendering a single texture, but optimizations are easy, and the engine can currently render multiple GIS tile datasets if set up for that kind of thing. Looking at WebGL Stats, we can see that the max texture resolution supported by WebGL compatible hardware is 4K textures. 70% can run 8K and 50% can run 16K. To reach the most users, we should target 4K textures for all scenes, which will require splitting up the WGS84 demo to use multiple smaller textures. In this specific case, only 2 4K textures are required. But for higher resolution planets, we will need to split the texture into smaller pieces. A 8K by 4K texture consumes 96 megabytes of RAM, which is pretty small for the level of detail produced in the scene. However, if we set our targets for minimally supported VRAM to be 512 megabytes, then that single texture is using about 20% of the total target memory. WebGL has no explicit way of displaying how much memory is available on the device, and WebGL can typically oversubscribe the amount of GPU memory on the device by 2x to 4x depending on specific hardware. This makes speculating an appropriate target for maximum GPU memory difficult. We might start at 512 megabytes and then move up to 2 gigs of GPU memory as a target as the game art evolves. This image was rendered using Blender Cycles, which is a path tracing rendering engine. We used various textures produced by NASA, such as color map, elevation map, cloud map, and ocean map textures, and baked everything into a single output texture, which is currently being displayed. This is an optimum strategy for creating high detail textures, while also minimizing the amount of required GPU memory as the texture is baked offline. We did the same process using NASA's moon textures, and achieved the result currently being displayed. The moon lacks atmospheric and weather effects and is a prime candidate for employing procedurally generated textures. This would allow producing mass quantities of rocky moon-like planets extremely quickly. We will end by displaying the Blender Cycles baked texture described previously on top of the WGS84 UV sphere model. We can see that the level of detail has been enhanced while the required texture memory has remained constant. Since the asset generation occurred offline, we do not require loading multiple textures at render time to display the final result. Combining Blender Cycles texture baking with procedurally generated textures is a possibility for creating a large amount of planet assets while using very few input texture resources. As you can see, the night skies texture blends seamlessly into the daylight texture. This method allows enhancing texture detail at the cost of losing lighting flexibility. The night and day regions of the planet are fixed and can't be changed since the texture lighting is baked into the base texture. OpenGL texture arrays would allow loading the individual textures and performing dynamic lighting at render time, but increase the cost of the render since 5 different textures need to be sampled. Obviously, the details of the gameplay should dictate which method is optimal. Since the gameplay has yet to be explored, we chose to simply state the rendering alternatives and defer any rendering techniques into the future when a clearer vision of the project has been created. This will conclude the development effort executed thus far in game engine development. Next week we will explore modeling spaceships, rendering with cube map textures, and generating environment maps such as stars and nebulas. This is Beyond Dying Skies Development signing off.